I'm recording questions 11 through 15 for AP Physics. All right, so we want to know when the net force equals 0. This is actually a trick question. So F equals ma. Ma is the net force, and A is the second derivative of position. So check it out. X dot is going to be 3t squared minus 12t plus 9. X double dot is 6t minus 12, and that equals 0 when t is 2 seconds. So when the acceleration is 0, that's at 2 seconds, and that makes the net force equal to 0. Meow. Number 12. Ooh, so we have this block here, and let's set up our free body diagram. So I'll actually draw that right here. So I'm going to make this a little bit smaller just so I can read it. There we go. So we've got this force F. We've got the weight, which I'll actually write as mg. We've got the normal, and we have a friction force equal to F. Now here, I'm going to write this as F cos theta, and this vertical force is F times the sine of theta. So just a couple of things. The normal force is going to be equal to, well, let's get the acceleration. So I'm going to get F cos theta minus friction equals ma. I divide by m, and so this is what I'm getting for my acceleration. Now, next, the coefficient of friction between the block and the surface is here. I've got the normal force equal to F sine theta. Sorry, I know that n plus F sine theta minus mg equals 0. So my normal force is going to be mg minus F sine theta. So that means my coefficient of friction is going to be friction divided by normal force, and that's how I'm getting choice E. And then number 14. We have an object that's falling. Maybe it reaches terminal velocity. Well, this means the gravity force and the drag force are equal. This is not true. There, of course, is a drag force. There, of course, is this. There's no acceleration upwards because the magnitudes of the forces bounce. When we actually, at terminal velocity, have 0 acceleration at all, which means the forces bounce. Number 15, it's another derivative question. So we're going to take the second derivative. So that's going to be 7/4 t to the 3/4 when I take this, sorry, x single dot, x dot, the first derivative is t, and that's going to be 7/4 minus 4/4 because I need to subtract one, and that's t, 7/4 t to the 3/4. And then x double dot is going to be 7/4 x to the 3/4 minus 4/4, which is going to be 7/4 t, so there should be a t here, t to the negative 1/4. And that's how I'm getting choice E. So in our last video, we'll do questions 16 through 20.